Welcome to the Databricks Skill Builder series. We're glad you're here.
Quickly, some introductions. My name is AJ Wellman. I'm a solutions architect. This is the Customer Skill Builder series that's being offered by sort of a crowdsourced group of solutions architects with Databricks. Today, we're going to be talking about Delta Lake. You do see another name, Tim Sepp, on the slide. Tim, unfortunately, had a family emergency, so I'm going to be running solo today, which is no problem, although I will be multitasking just a little bit. So you should be able to ask some questions in the Q&A area, and I will be answering questions probably live here, just over voice as opposed to responding in the chat window there. So yeah, ask questions and I'll get to as many as I can, and I'll build in a couple of stop points into the presentation today. There will be sort of a hybrid presentation. There'll be some deck to talk about positioning Databricks and the Lakehouse platform and Delta Lake and the significance of Delta Lake in the Lakehouse platform. And then there'll be a demonstration portion to actually see it in action. Do note that the demonstration portion is going to be through the lens of Databricks. Delta Lake can be used outside of the Databricks platform, but I'll be demoing it through the Databricks platform. And with that, I'm going to go ahead and kick off and get started. Again, just a reminder to go ahead and pop some questions in the Q&A if you have them, and I'll try to get to as many as I can. Why Delta Lake? Why did I personally select to do this presentation, and what's the logic of sort of having it separated out? There's a lot to the Lakehouse platform, as you can see in the image on the right, but honestly, Delta Lake is the underpinning of it all. There's really so much to be said, and so much I will say during this demonstration, but if I could sort of focus on maybe one or two things here. Early on, probably the most significant thing is that it runs on cloud storage. Databricks has a hybrid architecture, and clients are not required to move data from their cloud into our cloud, or they're not required to copy or clone, or it's sitting on your object storage in your cloud. And there are really so many benefits to the client for that. Chief among them is cost. It's the most economical way. You also have all kinds of options for retention policy if you want to, say, archive data of a certain age into, deep archiving, things like that. Also gives you the opportunity to move data across clouds. And so there's just so many benefits to that, and really sort of unlocks the value of Delta being open source and not locking clients in. And the other theme we'll really touch on a lot is the performance aspects of Delta and reliability as well. But again, it really is the bedrock of the Lakehouse platform. There will be some areas where I'll try to be clear. There are things that have been added on top of Delta within the Databricks platform to extend Delta. And so I'll try to be clear about the differences between that when I'm speaking, and also when I'm showing some demonstration. So at Databricks, we really like to talk about data and AI and how disruptive it's been to the industry. You can see, some of the largest FANG companies in the world, and Twitter, obviously still a company, while maybe not still public. These companies are not only leading in terms of showing by example how to use AI and data to make a business model and build a moat, but they're also contributing many innovations back to the community. And there are lots of optimization ideas and storage ideas and all kinds of things come out of this community of companies that are doing data and AI. And you can see, we like to talk at Databricks about the data maturity curve here. And on the y-axis is your competitive advantage. Competitive advantage can definitely mean more than one thing. Getting return on your investment is the best way to think about that. And that return can be in the form of operational efficiency, can be in the form of competitive advantage, can be in the form of actual revenue, can be in building a moat. I mean, there's all kinds of ways in which clients can use data to be to really create an impact and make their business stand above all businesses and businesses within their industry. And then at the bottom on the x-axis is the maturity. And we look at it in terms of use cases. You can see the sort of 7 use cases we've highlighted here in 2 different colors. The blue use cases tend to be more backward looking. So it tends to be things on, what happened in the past, using data to do, ad hoc analysis or reporting, and maybe do some sort of, inference by maybe eyeballing things or maybe reporting things. But on the right, as we move into what we'll see in a moment, is really more data lake type use cases. You're looking at prescriptive analytics, automated decision making. So you're looking at using machines and algorithms to make decisions for you, and again, really kind of create that competitive advantage. The problem is it really hasn't been easy for clients. There's a lot of things to say about this particular slide, and so I'll try and keep it kind of concise. But the first one is they just so much data right now. It's hard for clients to understand how to use it all. That can be everything from spreadsheets to obviously click behavior to data coming off IoT devices to there's really no shortage of things that are generating data today. But that data is of varying degrees of quality, and it's in varying degrees of structure, and clients have to figure out how to make use of all this. So you can see Gartner estimates that about $3.1 trillion annually is lost to poor data quality, and not being able to trust data when it comes in. And that one really resonates with me. I've been working a lot lately with clients who are really kind of excelling in the area of governance and trying to really make data as a quality product that's available to other aspects of the organization. I think probably many of you on the presentation here have probably experienced where you're trying to look for some data within your organization, and you find some group that maybe has the data you need, but you're not really sure the source of it, what kind of quality it is. Maybe you don't have access to it. Maybe you need to get credentials through, some type of IT ticket to a different system. And so it's really important for not only the quality to be there, but for the company to create ways for everyone to access that data. And then that sort of leads to the last point, which is that the majority of the data goes unused. Clients spend all this time gathering data. They have it in various locations, and ultimately it's not really used. Traditionally, data warehouses, served this purpose for organizations. So going back to the maturity curve, the use cases on the left, those are all pretty ripe for data warehouses. Data warehouses are starting to shift to the cloud, which helps some of the problems associated with data warehouses, namely scale and being able to horizontally and vertically scale, and save on costs associated with increasing data centers, buying more data centers, and those things, but really hasn't fully solved for the issues around the complexity of data, namely video and streaming, and just there's so much different types of data, and data warehouses aren't natively built to support that. Additionally, it can be really costly to run a data science workload on a data warehouse. And time is money, of course, and it's also a lot of frustration. Imagine being 6 hours into a machine learning model, and your data warehouse runs out of memory, and your machine learning algorithm stops, and now you've lost 6 hours of time that you've got to start again. And then finally, they're closed, and they're closed for a reason. It's for efficiency. That having very, very tight coupling of their compute and their data formats and the location of the data allows them to get efficiency needed for performance. And obviously that's a very positive for the end user until they want to do something else, until they want to move that data to another location, or they want to tap into that data with another system, and then the closed nature of it becomes problematic. So data lakes were built almost as sort of a polar opposite to handle all of the inefficiencies of a data warehouse and support the data science use case. The downside, though, they came without all of the features that a data warehouse has natively. Data warehouses have a ton of security features built in, for example, roles and grants, and making sure people have access to only the right data. They have the data all sort of co-located together in one place, which is an advantage. You're not searching all over the place. And again, performance is really an advantage in a data warehouse because of that tight coupling of the compute and the location and the nature of the files format. So this is kind of a summary of the various problems that we see with data lakes. The first group here being sort of reliability issues. If you're trying to run a machine learning model on some Parquet data and it fails halfway through, or a feature store fails halfway through writing your features out, then obviously you're going to have reliability problems, and you may not know what the truth is anymore. You may not know which records are good, which records are bad. And you also have to keep multiple versions of the data around. So you have to be able to roll back and understand what's changed. Appending data is something that a lot of our clients have found ways to write their own appends, but that usually revolves around cloning and copying and moving data and many lines of code. And with Delta, we're able to offer that kind of right out of the box. Performance is something that at Databricks, we spend a lot of time tuning Delta and helping clients tune their Delta to handle a lot of the downsides of a data lake. You can kind of see the ones that are listed here. I think the too many files problem is definitely one of the biggest. Just data kind of all over the place and super small files. Imagine millions of 1 megabyte files coming off an IoT device, and every one of those requires disk time to be opened and scanned. Where if we could maybe compact that, then we can get some performance. And then also the way that the data is organized with Delta. We're able to keep track of usage patterns and understand if you're doing certain types of queries, and then you can do optimizations built on your data that will help kind of organize it better for performance reasons. And quite frankly, we really are able to get just as much performance, most of the time out of Delta as you can get out of a data warehouse. So we really have become sort of bleeding edge in terms of cost performance on that issue there. And then access control. This is an area that I sort of mentioned there's multiple levels here. You are able to build access controls within Delta on top of Delta tables, and that was sort of the traditional way that it was built into Databricks platform. But we also have a new tool, Unity Catalog, which I will be just sort of briefly touching on, so you can see how Unity Catalog handles the Delta and showing governance related issues around Delta within the platform. And then finally, quality. There are quality expectations built into Delta. That's something that people who are used to working in a data warehouse are very used to. You define a table as maybe not null, and then an insert fails if somebody tries to insert a record that's null. Well, doing that into a Parquet file, of course, there's nothing inherently to stop that from happening. And so Delta comes with what we call quality expectations built on top. And your quality expectations can reject records. And there's all kinds of expectations you can define from, whether a record is null to, maybe the nature of the data, or if it's a date, maybe a date range, things like that. And so Delta was, as I've sort of just demonstrated, brings together the best of a data warehouse and a data lake, adds reliability and in a lot of the functions that you're used to seeing in a data warehouse, also brings the faster processing time with indexing. So it brings that performance and brings the governance and the access controls and things that are necessary for the enterprise and really making business ready applications versus maybe sort of things that are a little less reliable, and it brings all that to a data lake. So quickly summarizing our set of problems into solutions here. The first 5 are all handled with transactional guarantees, which, if you're familiar with data warehouses, the term ACID is frequently used. The next set are performance related with indexing and optimization. And I do have one example of that I'll be showing. Governance with table ACLs. I'm really going to be showing that mostly through the Unity Catalog, which again is a separate feature in the Databricks platform, and then quality expectations. Did sort of cover most of this, but just a couple things that I'll highlight. Time travel, that's something I'm going to be showing in the demonstration. A lot of power and be able to roll back and see prior versions of data in the case of failure. Your data engineer may have to get involved if a job fails and understand what happened, understand the nature of the job that was running. No vendor lock-in, we talked about that already, but just again, want to sort of highlight the significance of that. And I think I do have one more slide talking about what it looks like on disk and how you see the Parquet. And then Economical, again, I already touched on that as well, but again, this is really the lowest cost way to build a enterprise scale data warehouse on the cloud. It's very simple to load data into Delta. This copy into command can read data directly off a disk in the form of S3, which is kind of the example shown here. It's also used by all of our ingestion partners. Fivetran, Archeon, Matillion are three that stand out. So you're loading data from a number of different data sources directly into Databricks using this copy into command. Another way to, and yeah, it's important to note that this is, it's all guaranteed. So you're guaranteed this process is repeatable, it's incremental, so when you do your next load, it picks up from where it left off. And jumping over to the next technology here, autoloader. Autoloader is built within the Databricks platform. It's a feature of the platform. It's built on top of Spark Streaming. And then on top of that is actually a tool called Delta Live Tables. So it goes Spark Streaming, Autoloader, Delta Live Tables is sort of a foundation. And Autoloader allows you to read your data in and sort of is like a hybrid streaming format. Where it leaves off, it doesn't have to be running all the time necessarily, like people obviously, typically think of a stream. Instead, you can run this, every hour or every day, but it still acts like a stream in that it remembers where it left off and it picks back up again. So it has this exactly once guarantee and incremental as well. As I mentioned, Delta Live Tables, which there have been separate sessions on. Delta Live Tables takes this kind of to the next level, and it not only manages the process of reading data in, but also manages a lot of the infrastructure for you and a lot of the things that often slow data engineers down. So if you're interested in Delta Live Tables, I highly recommend joining a session for that, because it's super technology. We released it, I believe, in April of this year. So additionally, you can read data into Delta from all these different formats. Frequently, clients are looking to bring data in from something like Oracle, maybe in like an ERP system. They want to bring it to the cloud and they want to start doing maybe machine learning on it, or they want to start joining it with their data from Salesforce or Marketo. And we're able to ingest data into Delta from all these different formats, either using a partner, Fivetran, Archeon, as I mentioned before, or autoloader, as I just sort of demonstrated a moment ago. And now we'll sort of talk about what it means to be open. All these are connectors that can actually read Delta format. And what that means is, the combination of the data sitting in your cloud and the ability to read the Delta format in multiple tools, you could, in theory, have multiple products reading your data at the same time. Now certainly we'd urge caution and good practice in terms of architecture on that, because it could get dangerous having multiple applications reading your raw data at the same time. But it's possible, and it's also possible to lift and shift this data to another cloud. And so it's truly open. You're not locked in to one particular format. You're not locked in even necessarily to going through Databricks to retrieve this. While you can say use something like Power BI and do a direct connection through the Databricks platform and read your Delta, you could also do that raw. Another pillar of the Lakehouse and what Databricks is building is cloud independence. Well, it's our belief that clients will eventually probably have a presence in all clouds. Very common today to see clients who've maybe merged with a different business unit or acquired another company, and that company has a different cloud technology. Also, the clouds themselves have different strengths and weaknesses, and oftentimes clients want to do a certain type of analytics or use a certain process on Amazon or Google. And then finally, while it's probably not ideal for most clients, there is always the potential that you want to lift and shift to a different cloud. Maybe your new CTO decides that Amazon is not the vendor you want to work with, and you want to move to ADLS. It's possible, and doesn't have to incur dramatic change on your behalf. So having Delta be cloud independent is a very big advantage for clients. I I referenced this slide a few minutes ago. Delta, while at its core, it's Parquet, there's also a very important protocol written on top of that. And the protocol brings all the benefits that we've been discussing in terms of performance, ACID transactions. There's metadata that's literally just sitting right next to your Parquet, and that metadata allows Delta to do all of the different functions that we've talked about, keep track of versioning and history. Even some optimizations are built in. So the metadata is keeping track of your query patterns, your usage patterns, your loading patterns, and all that can be used when optimization needs to be done. So at its core, it is just Delta, or excuse me, Parquet, and you can take just the raw Parquet and just move it literally from one location to another. But obviously the metadata that's on top of that is where the real value is added. And finally, common thing we hear is, well, I already have a bunch of data in Parquet, and I don't know what I'm going to do, and I don't know if I want to use Delta. Well, it's easy with one command to bring all the data in to Delta from Parquet. Very straightforward, and something that our clients are doing almost every day. And with that, I'm going to go ahead and start a demonstration. I'm looking up here. I don't see any questions at the moment. So I will go ahead and motor on to the demonstration portion here. Just as a word of warning to the group, I am a football fan, and in particular, I'm a Denver Broncos fan for life now, for better, for worse. And so take everything I say about football with a grain of salt, because I am a fan, and the very definition of the word, a fanatic. So we're going to be loading some raw data from this NFL API. In particular, we're reading in 5 years of data, and then we're going to showcase the power of Delta Lake through that, and first loading it and then doing some operations on it. I just went through roughly 20 minutes of slides, so I'm not going to talk too much more about that stuff, but it's probably worth having this quick summary and just sort of highlighting the key benefits of Delta once again. I will mention that Delta was prior to Data and AI Summit this year, where we announced Delta 2.0. Delta did have features that were available in the open source version, namely those from this above. And then a lot of the performance related issues were actually managed within the Databricks platform and sort of held aside for Databricks clients. As of now, with Delta 2.0, everything has been open sourced, and all of these features that we're seeing will be available within open source Delta as well. First thing I'm doing here is just kind of setting up some variables for my notebook. I'm going to be reading the data into a Unity catalog named November Delta presentation, and into a schema called NFL data _ AJW. As I mentioned, my partner, Tim Sepp, who originally did this, was not able to join, so I created a different table from his for the demonstration purposes. And then here we're just reading the data from that API, and we're going ahead and doing our initial write into Delta and the Databricks platform. And so what that looks like, I may have to shift my screen just a little bit here. What that looks like is, if I go into the Data Explorer and I go to my catalog, November Delta presentation, and actually I now have a new table in here, NFL data _ AJ. I can see the details about this information. So these are Unity catalog features. And once again, Unity catalog is a new feature of the Databricks platform. This was released in about the August timeframe. It's been a pretty, I'd say, massive, almost revolutionary change to the way we operate within the Databricks platform. So while there are access controls natively available on top of Delta, Unity does that for you, and Unity manages all that across the entire Databricks platform. So I just want to be clear that some of what you're seeing here is actually Unity catalog and built on top of Delta. And you can see this is the table that we read in. You can see that it's Delta format, and I can look at some sample data. I can look at the permissions, who has it. We're going to talk more about the history of the data in a few minutes, and what history looks like and the significance of that. Lineage is a feature that comes with our Unity catalog tool, so you can see how a table is, used throughout the whole product in terms of, what feeds into it, what feeds out of it, and you can keep track of that lineage. This has been a really popular feature, and in fact, for me personally, probably the most commonly requested feature to be enhanced in terms of clients want to do all kinds of stuff. I talked earlier about governance and how important it is for clients to understand all their data and where all their data is. Well, this is just another aspect of data, is understanding, what feeds into what. Okay, I have this great NFL data here, but where did it come from? What was upstream from that? What's my risk if something upstream changes from that? Oh, wow. As luck would have it, I just logged out. So let me log back in here. Thank goodness for SSO. And all right, so that's what the data looks like in the Unity catalog, and the permissions, only giving permissions to myself on this data. All right, so let's get going here. First thing we're going to do is now that we've loaded the data, let's go ahead and take a look at it. And there looks like there's about 50 columns, so this is pretty flat data coming from an API. But we can also see the storage location on disk. It's being stored in an S3 bucket. It's in Delta format, and it's a managed table. Managed versus unmanaged is something to be very aware of within the Databricks platform. Generally speaking, the primary difference is what happens to your data upon removal. If it's managed, the data itself will be deleted. If it's unmanaged, you'll just be deleting the reference to it on disk. So that's something to be very aware of, is the type of whether it's managed or unmanaged. And also, when you're creating data, you can control whether you want it to be managed or unmanaged. So pay attention to that, and that's available here in the looking at the describe on the table. Now I'm going to go ahead and take a look at my first sample query from the data, and I'm looking at who the Miami Dolphins quarterbacks were for this season. The reason I picked that specific use case is I happen to know that Tua was injured for part of this season, so I can see Teddy Bridgewater was the quarterback in the weeks that Tua was injured. So the data looks clean, that looks good. And now let's talk a little bit about the version history. First thing I can do is run a history command and just see all the different versions the data's gone through. Now, this is versioning kind of, think of this as a table level operation, like what happened, what was going on when this version was created. The initial version was when I ran the API call, and I did a create table from that API call and wrote it out to disk. And then I'm actually a little bit ahead of myself because I've already run this, but I'll show you in a moment. I've also done an update to the data. So that's version 1. Version 0 is the initial create. Version 1 is when the data has been updated. So that's actually what's happening down here. This is where my being a fan is gonna shine out. I just went ahead and cheated, and I went ahead and signed Tom Brady to Denver. Obviously that's not realistic, but what team doesn't want to have Tom Brady, one of the greatest quarterbacks in history? So that's why you're seeing this record up here. Again, I've already run this command previously, and so as this version 1, I've assigned Tom Brady to the Denver Broncos. And now if I go and look at Tom Brady in my data, you'll see that just has it happened in reality until fiction. Tom Brady was on the New England Patriots in 2019. He signed with the Tampa Bay Buccaneers in 2020 and 2021. And then I have gone ahead and assigned him to the Denver Broncos. That's the fiction piece in 2022. And what that looks like when comparing versions is this. I sort of cheated by having this already done. So it looks like I can see the create or replace, I can see the update, but where it gets really interesting is now I can run and I can compare what happened or I can look at what happened in version 1 of the data. So I can look at the changes, and you can see that it's isolated exactly those records that moved Tom Brady to the Denver Broncos. This is what it looks like in version 1 now. But if I go back to version 0, I will see what the data looked like before my change, and you'll see that Tom Brady was previously before my update on Tampa Bay as of 2022. That's a little bit of an ad hoc, sort of intuitively working with the data way to understand that. But here's a better way, which is actually just comparing version 1 to version 0. And we're going to go ahead and just isolate the records that have changed from version 1 to version 0. And now you can see only those records where I assigned Tom Brady to the Denver Broncos in 2022 are shown. So lot of syntactic capability to compare different versions, to compare different what's happened through time. This is all being done literally looking at exactly the version number, 0 or 1, but you can also do this syntax and just use timestamp. What was known as of timestamp, X or Y or Z, that's possible as well. So again, that's sort of looking at it. Change data at the table level, but oftentimes clients want to see what's happening within an individual record. And so what I've done here is I've created a table called weekly data _ CDF, and I've turned on the change data feed property on Delta. So that's one thing that's worth discussing here, is that clients often ask me, well, what if I don't want change data feed turned on, or what if I don't want vacuum done? Vacuum, just by the way, is the process of cleaning up old versions of the data, because it is more or less copying your data on disk each time, and you may not want, let's say, 100 versions of your 100 megabyte Parquet file sitting around. So you run the vacuum command and clean that up. But all these properties are configurable, is where I was going with that. So clients can really sort of drive their experience with Delta based on their use cases and based on their desired behavior by setting various properties of Delta. And so here we're turning on the change data feed feature, and we're actually going to go ahead and create this table we're going to roll back to version 0 of our weekly data table. So we're going to reject my mythical Tom Brady update and put the data back in this weekly CDF table to version 0. and so when I run my describe history command on that, you can see that version 0 was the original create of that new table based on weekly data version 0. And now I'm going to force some additional updates as a Broncos fan. Been sort of disappointed with Melvin Gordon this year. He's been fumbling a lot, and so I'm going to drop him from the team, and I'm going to go ahead and add Derrick Henry in his place. The Broncos recently played the Tennessee Titans, so that's kind of fresh in my mind. When I run these two queries, that sparks about 9 different updates. And then when I go and look at that within the describe history, you'll see again, these are the table level updates. So you're seeing the update of the Derrick Henry, and then you're seeing the deletion of Melvin Gordon. So I'm physically doing a hard delete and dropping Melvin Gordon completely out of the database. Again, this wasn't necessarily meant to be reality, but just as a Denver Bronco fan. But now if I want to see the actual changes that are happening, that's what this query is going to be demonstrating for me here. So looking at the changes between versions 1 and 10, there were 9 records that we were looking at earlier. And so I can actually see Melvin Gordon was deleted, and I can actually see that Derrick Henry was added, and I can see all those changes in the database itself. So this is a way to actually isolate down to the record label what's happening and see the changes that are being made, again, with that CDF version turned on, or that CDF feature turned on. And then the last thing that we'll talk about is optimization. There are a number of optimizations built into to Delta. I'm by no means an optimization expert, but I'm going to go ahead and show a couple of those here today. The first is what we call the small file problem. So as I referenced earlier, you can have hundreds of like 1 megabit files written to disk from something like an IoT, or maybe it's really tiny Excel files that are output from your finance system or something like that. And so by running this optimize command, actually decrease the number of files from 8 down to 1. So condensed my Parquet from 8 files that each need to be individually opened and read and optimized down to 1. So now I have only 1 read time that needs to be done. That's one form of optimization that can be done. And that's probably one of the most common, just because that is very common in data lakes to have, multitude of files kind of all over the place. Very common too for like streaming related updates. After your first couple of streaming use cases, I had a client, they had like, I don't know, 110 files on their initial load. And then after they started doing some queries and some other things, they ran an optimize, and Delta condensed that down to 10. And that was just because of those optimizations that are built in, and Delta understanding the best way to optimize that data. So Z ordering is a technique used to sort of put data that's like together in files that are located together in close proximity. So it's sort of a way of partitioning data, if you will, and bringing data closely together that's commonly going to be queried together. You can see down here, there's a couple of best practices. One is data that has high cardinality. So that is that it has a large number of distinct values. Then you want to use the Z order by. Here, I went ahead and optimized on the season. Theory there being, maybe I'm looking at some fantasy football stats, and I want to go ahead and bring data together by the season. And that way, if I want to know, hey, what was Tom Brady's, weekly performance in 2022 for fantasy football reasons. And then those were, by the way, columns that were captured in my feed. Then I can go ahead and Z order that. Practically speaking, that didn't do a whole lot in this case because it's just an example, and it's also sort of a single table file. So didn't add a lot of benefit here, but just sort of highlights the idea of what Z ordering is and why it's significant. And this is one of the best optimization techniques, along with file compaction that's offered by Delta. And with that, I've covered pretty much all the material that I want to cover. I do see 2 questions, and I will try to address both of those as best I can here. Let's see. Do we have performance metric statistics between Delta and Power BI? Generally, is not recommended to pull the data from Lake and Power BI because of performance. Performance is a very sort of individual use case question. Most of the time, there's a lot of factors in there, network latency, size of data, things like that. I will say I can provide, if I have a minute here at the end, I'll try to find it, a blog post that one of our solutions architects did around bringing in trillions of records into Power BI from Delta. So I would say we encourage clients to start first with a direct connection and to try to pull the data and use some of the techniques I've described here, optimization techniques to try to make sure that you can connect to live data. Any kind of extract tends to become just another form of data and a potential for a data silo if it's not refreshed and things like that. But there's definitely going to be use cases where it might make sense to not have a live connection. So we've been able to do it with millions of records and petabyte scale, but your particular use case might be different. Thank you, Mimi. I think I just got a copy of the blog post, and I will actually toss it in the chat for everyone. And you're welcome to, oops, that's not what I was looking for. See if I can highlight this. Oh, there it is. Well, it just came up. So this is the blog post I was referring to from Kyle, and Kyle is one of our very, very smart Databricks SQL SMEs. And so I will post that into the chat. Thank you again, Mimi, for that. All right, and then next question is, will Unicalyx show lineage if removed the data outside the lake like SQL Server and do, right. Very common question. Right now, lineage is only for data within the Databricks platform. It's basically built by the logging and the metadata that's dropped by Spark during various connections, or sorry, various operations. And so it's only within the platform. The couple of known limitations to that right now, in addition to the fact that, it's only within the platform. The other one is we do limit history to 30 days. So clients will be able to basically extract that history if they want and build it out, and then they'll be able to keep more than 30 days. We'll probably at some point offer a configurable number on that as well. For clients that want to do more enterprise scale governance and want to use that, outside of Databricks and including things like SQL Server, which was one of the questions, then you can export the data. We have an API for Unity that allows you to export the lineage data and then take it into, any one of, Muta, or I think one of the clients I was referencing earlier, who's doing this stuff really well. They are using, geez, I'm losing it. Parajot, I see you're on. If you could remind me what the tool is. But yeah, so you can take the lineage outside, and you can do enterprise lineage by extracting it out of Databricks and using it in your other tools. Let's see. So that's all. Yeah, there was another one I was thinking of. Parajot. All right, so I don't see any other questions at the moment. It's the top of the hour. Does anybody have anything else they want to ask? Or if not, I think we may be done for today. Elation just came to me. Elation was the other tool I was thinking of, that a client's using and doing enterprise scale. They were one of the most sophisticated clients I've seen in terms of having a process for trying to really use data as an asset across the whole organization and publish quality, and they divide their data into tiers of quality, and yeah, they organize all that using Elation, and that's how members of their organization find out what data is available, what the schema is, where it's located, and again, they're going to be exporting data out of Databricks' lineage from Unity Catalog and into Elation. So I did see if we could share the limitations. I will see if I can find that document. Let me see. It might be in the release notes. Yeah, I don't have that handy. I apologize, Sunil. I'll try to see if I can follow up with that after the webinar here. All right, well, that was the end of the questions, and that's the end of the presentation. Thank you again for joining today. Thanks to Mimi and Parajot for the assists. I just do want to plug this series. I think it's been a really powerful series. So do continue to sign up and contact your SA if you're not sure what the upcoming sessions are. Thanks, everyone. Have a great day.